is the unit circle. Anybody know why they call it a unit circle? It's a circle with units, kind of. Anybody know the radius of a unit circle? 1 unit. There it is. Okay? So, if we have a unit circle, that means that its radius is 1. And that's going to be about as good of a circle as I can, but it's not 7. Okay? So, what that tells us is, I know that this goes over 1 unit, so its coordinate point must be 1, comma 0. Okay, that one means it's up 1 unit. Okay. This one's over 1 unit. And the bottom piece would be down 1 unit. Right. So the fact that it's a unit circle, I don't know if it's a mile, I don't know if it's an inch, I don't know, whatever piece. You need to see.
I'm just standing against the wall.
Fair enough. Okay. And so I was like, I think we got enough tables in here now. They added chairs, I saw. We have 36 seats now. So we have these 4 key coordinate points, which we can find based on the fact that this thing's called a unit circle. It's 1 unit in radius. Which point do we want to start on when we talk about measurements of an angle? The top, bottom, left, or right? The right side. Perfect. So this is where we start, which is how many degrees? 0. And how many radians? 0. There's our starting point. Okay. If we were to go around, which we always rotate around in a counterclockwise direction to measure our angles, and I made it all the way back around, how far have I gone?
2 pi.
Good. 360 degrees or?
2 pi.
2 pi. Okay. If you guys know that, you can pretty much build the rest of this circle, and then we'll use some right triangle trig stuff to find all the coordinate points. Okay. So I have a full circle. If I were to cut this in half, how many degrees do I have? 180. Or how many radians? 5 radians. Good. Okay, we just cut this thing in half. If I were to cut that in half again and get up to this top piece, how many degrees am I at? 90. Or how many radians? Good. If I cut this in half, half of the pi is pi over 2. Okay, so that's how many radians I have. Now, if I want to find this 3/4 mark, I can basically add 1/4 with 1/2. So 90 plus that 80, 180, will get us to 270 degrees. Or radians, I have 1 pi plus a half pi, so I have 3/2 pi. Or 1.5 pi, if you want to think about it that way. Okay, so that gets us that radians. So now we have the 4 main key pieces. The next one, we're going to continue cutting it in half. We'll go in half again here, which will give us 45 degrees, or half of a half is 1/4. Okay? So we're going to end up with pi over 4. That'll help us with the radians. Okay? Then I want to start thinking about how do I actually find the coordinate points to this. And so one of the things that, if you don't already have it memorized, because a lot of us have probably seen this in Algebra 1 or geometry or something like that, those special triangles. You guys remember what a 45, 45, 90 looks like? Jesse?
What are you talking about?
What's our side lengths?
Root 2 and
Yeah. So if we said that this has a side length of 1, or whatever it is, this is whatever the side length is times radical 2. So this might have been one of those things we've seen. Okay. Another big concept to know, and hopefully you guys saw this while I was gone, is that the coordinate point on our unit circle can be written as sine comma cosine. You guys remember that? So if you have the coordinate point x comma y on this unit circle, it's basically your cosine comma sine. And so what we're doing is we essentially are building this right triangle here, and this is our 45, 45, 90. So if I want my coordinate point, the cosine of this angle is 1 over radical 2. And 1 over radical 2, what do we not like about that? The radical. So how do you undo that? Good. We want to multiply it by that radical 2 over radical 2, because that rationalizes the denominator. So our coordinate point becomes radical 2 over 2. That's where that number comes from. Okay, it's from that special triangle. And then the same idea with sine, so opposite over opposite over hypotenuse, is also the radical 2 over 2. Okay, that's where that coordinate point comes from, how we find it. The next piece we're going to take a look at is our, what's the other special triangle we like? Good, 30, 60, 90. So, same idea, we're building this 30, 60, 90 triangle here. And so, if we remember the special triangle, this is the one where the short leg is 1, the hypotenuse is 2, and the long leg is radical 3. Okay. Exact same idea. How many degrees is that? We said it was 30. So how many radians would this be? Good. The way I try to remember it is I go, okay, well, I knew that 180 divided by 30 is 6. So this must be 1/6 of the half. So it's 1/6 of pi. So we end up with pi over 6. And then our coordinate for it, our cosine is adjacent over hypotenuse, so radical 3 over 2, comma, opposite over hypotenuse, 1 over 2. So now we have our 30-degree mark and its coordinate point on the unit circle. Those are really the only ones you need, because 60 is the exact same triangle, just flip-flop. So now this triangle is stacked tall, so it's 1, 2, radical 3. So 60 degrees. Now 60 degrees is 1/3 of 180, so this must be pi over 3 radians. And then our coordinate for it, adjacent over hypotenuse is 1/2, and opposite over hypotenuse is radical 3 over 2. Okay, it's the exact same coordinate, just flip-flop. Okay? And that's all you really need. Because then what you end up doing is, let's say I'm like, hey, fill in this one for me down here. And you know that it's the one that's opposite the 45. So you're like, well, I know that this is 180 plus 45 degrees, so it's 225 degrees. Or it's pi plus pi over 4, so it's 5 pi over 4. So now I have the total radians there as well. As far as the coordinate, it's the exact same coordinate point. It's this radical 2 over 2. Well, what's the only difference? They're both negative, because I'm in that third quadrant. So my x is negative and my y is negative. So this is negative radical 2 over 2 and negative radical 2 over 2. So it's the exact same coordinate point. You don't have to memorize a bunch of stuff. Just know this one and then apply it to other places. So we could also have something like this one up here. Okay, so I know that this is 120 degrees. Or if I double this, this would be 2 pi over 3. And then it's the exact same coordinate point as we had over here. So this is still 1/2 radical 3 over 2. But the only difference is now my x value is negative. So I need to make that into a negative. Okay? So you can build the entire unit circle, but realistically, all you actually need is these 2 coordinate points, or 3 if you include the green. Okay? And then you can reflect or add and move these things all over the place and put it wherever you need to. Okay? So hopefully that'll kind of help you with building the unit circle. Okay? Questions on that part? So the next piece we're going to take a look at then is the sine functions. So hopefully you've done a lot of stuff with amplitude and period so far. And what we're going to do today is start shifting things up and shifting things down. So if we start super basic with stuff we're comfortable with, how do I shift the function y equals x squared up 2 units? We just plus 2 to it, right? Good. So if I were just to add 2, this thing shifts it up. Okay? If I wanted to shift that now towards the, let's go right 3 units, what would I do? Jesse?
You do the x minus 3.
Good. Okay, so when we do stuff on the inside, it will move us left or right. In this particular case, we'd go right 3 units. Okay? the exact same concept is going to get applied when we do our sine and cosine graphs. Okay? So something that I think is good to at least point out, since I haven't been here in a while, is when you graph your y equals sine of x, you normally will start at 0, 0. On a unit circle, it will go up to 1 and down to negative 1. And it will happen over the course of the 2 pi. Okay? And whatever that period is, then I would go and cut these into quarters. So I'd cut it into half. In this case, it's pi. And then cut that in half again, so pi over 2. And then I would add these two together. So I end up with the 3 pi over 2. So these are my 4 key points. So I start at 0, 0. I go to the top. Let's do this in a different color. I go to the top, come back to the middle, down to the bottom, back to the middle. Okay, and so this kind of helps us build a generic sine graph. Okay. Whatever that period ends up being. So in this particular case, we have a period of 24. So the halfway point is at 12, the quarters are at 6 and 18. So those are your key pieces when you go to graph those. Generically, and this is how the book will have it written, you'll have y equals a times sine of bx minus c plus d. That's the generic equation for your sine function. And then let's kind of talk about what each of these mean. So A is our amplitude. That's that height. B is the coefficient in front of x, which B is actually made up of a traditional full lap, which is your 2 pi radians, divided by whatever your period actually is. Which is why when your period is 2 pi, the coefficient in front of x is just 1. Okay? So P is your period. And then your C, based on what we just looked at up above, what will C do? Stuff on the inside, good. It'll shift us left and right. That's the horizontal shift. Okay, things that go left and right. And then the D value would then be up and down, which is our vertical shift. Perfect. Okay, so that's how we can shift things left, right, up, and down. So the first few we're going to look at are just very standard, like, estimates of things. And so state the amplitude in the period. So if we looked at this one, what's our amplitude? Hopefully everyone together. Amplitude of this number 7 is 50. Good. So the middle line here is at 0. We go up to 50, down to negative 50. So our amplitude is 50. Our period then, we do 1 full rotation by 24. So our period is 24. Okay? Which, if we're looking for the B value, that means 2 pi over 24. Which can reduce to pi over 12. This is very common. You'll see this a lot. Anytime you deal with something that has to do with like average temperatures of a day or something like that with a 24-hour clock, this will end up being your B value. So the equation of this line then is y equals 50 sine pi over 12 x. We're not shifted left or right. We're not shifted up or down. So our C and D values are 0. So that is our equation. So now we can create an equation from a graph. Yes? B is the coefficient that goes in front of x. So generically it's that. B is made up of 2 pi divided by P. Because 2 pi is a normal circle. Okay? So now we can answer the rest of the stuff. Estimate the value at x equals 14. You could actually plug in 14 for x and figure out where it is, or based on this picture, you can say, okay, well, there's 14. So estimating it looks like it's about 25. Okay, so f of 14 is about 25. Okay, we're just estimating. And then the other part is estimate the interval from 0 to p. That's saying in one lap, one time through our cycle. When is this above 20 degrees, or 20, whatever the value is. So here we figure out, well, there's 20. So we recognize that this is the portion we're looking at. And so we're going to say that this occurs when x is from 2 to 10. Okay, so that could be our rough estimate of our interval. Okay. Yes, Spencer.
Where did you get the amplitude of 50?
So I know that I go up to 50 and down to negative 50. So the average distance, I go a total of 100. If I cut that in half to find the middle, I'd go 50. Which we're going to look at that a little bit more specifically because sometimes it's not always centered at 0 once we start shifting things up and down. Okay? We okay there? Yeah.
So
Like,
f of 14 equals 25. Well, can you explain that one more time?
so that was just my estimate. I just went and said, okay, here's x equals 14. I'm going to figure out what my y value is. Oh, negative.
Oh.
It should be negative. That's my fault. Negative 25. There we go. So my y value is negative 25. Good catch. Okay. So the next piece we'll take a look at then is what if it's not centered around 0? So one of the common places you'll see this is like a Ferris wheel. So like a Ferris wheel usually has that giant support that holds the wheel up in the air. And so maybe at the top of this ride, it gets to 100 feet above the ground. And at the bottom of this ride, will be about 20 feet above the ground. Okay? So if we're looking at number 11 here, we're going to deal with something that has a maximum of 110 and a minimum of 20. And if we're looking at this as a graph, what we're seeing is there's going to be a maximum up here at 100 and a minimum of 20. And so I know this is going to take me a period of 30, so whatever that means, maybe it takes me 30 minutes to make a full rotation around this Ferris wheel or whatever it is, okay? So our amplitude will be 30, the period will be 30. And so if I'm graphing this, that means way over here, we'll do a full lap. Okay? And then I want to use this information to build an equation. Okay, whether it's sine or cosine, that's what the sinusoidal equation is. We want to either use sine or cosine, doesn't necessarily matter which one, to represent this equation. So what I basically need is that middle line. How can I find that? So my amplitude is 100 to 20 is 80. So my amplitude then is half of that, so 40. Good. So my amplitude will equal 40. That's the distance from the middle to the top. That's our 40. Okay. Our b value is the 2 pi over our period, which our period is 30. So we'll see that this ends up being pi over 15. Okay, so now we have a b value. Am I shifted left or right? I have no idea. It doesn't really tell me anything about that, so we'll assume no. We'll make it more simple. Am I shifted up or down? Does this thing start at 0, 0? What's the support at? The middle of that circle. What's 40 from 100? 60. So that middle beam there is at 60 feet above the ground, so to speak. So this middle bar here, the thing in between 120, is 60. So now I have that middle bar, which tells me I have a vertical shift of 60. That's our d value. Okay, so now I can go build my equation. My equation from all this information can say that y equals 40 sine pi over 15 x plus 60. Okay. So that'll get me that complete vertical shift with our amplitude and period. And if I wanted to graph this thing, we could find the key pieces. We'd be at 15, 7.5, 22.5, and then we can go find our key points. So this will end up being, we'll start at 0, we'll go up, back to the middle, down, back to the middle. And then we're able to build. So if this happened to be the Ferris wheel, we could graph the height above the ground over time, assuming that we load on the Ferris wheel somewhere over here. Yes?
Where it says b equals 2 pi over p, where does the 2 go in pi? And when it goes
So
to pi?
this is 2 pi over 30, because my period was 30. And so 2 and 30 will reduce into 1 over 15. Okay, feeling okay there? So this is if you have a vertical shift. You want to take the max and the min, and then you can find your amplitude. Still use the period to help us find the b value. And we'll move from there. We do that. Run over something else. Okay. Next piece, we're going to get into some of the story problem stuff. This will be the temperature in a day, average temperature in a day. And this will actually be very similar to a question I'll give you on the test. So in general, we're going to see that during the day, we'll have a high temperature, which in this particular case, they're going to say our high is at 39. We'll have a low that, in this particular case, they're going to say is 29. And usually throughout that day, you're going to go up towards it, back down towards the low, and then back towards the middle. So here, again, you're going to want to find that middle piece, which in this case, what's my middle? What's my average temperature for the day? 34, good, which tells me the amplitude then is 34 to 39 is 5. Okay. Or we could think of 29 to 39 is 10, so half of that is 5. So our amplitude would be 5. How long is a day? 24 hours, good. So our period is 24. So our b value then would be pi over 12. Perfect, okay? This is something you'll start to see a lot. Okay, the 2 pi over 24 for a day, so the b value becomes pi over 12. Okay, our c value, let's see what ends up happening. We're going to go with noon being our time equals 0. It doesn't really tell us when the maximum temperature is, what time of day, but let's assume that the temperature is the average temperature at noon. So we'll have a 0 shift left and right. So our very first, this will correspond to noon. Okay, so 0 will correspond to noon. I do have a vertical shift. How far up do we go? We'll go up that average, so at 34, okay? Oh, this is going to be, oh, there we go, okay. So this is going to be noon. Our D value, we have a vertical shift of 34. It gets us to that middle piece. And then we'll see that around our 24-hour clock, so this is going to be 6 p.m. This will be midnight. And then this will be 6 a.m. And we'll go back to noon again when we do a full rotation. Okay? That'll kind of help us as we answer the question later on. So we're going to go up to a high temperature at 6 p.m. We'll be back to the average at midnight, back to the low at 6 a.m. And then we'll get back to the average temperature by noon. So we have our graph. We can build the equation to this graph now. So this is our y equals 5 sine pi over 12x plus 34. Okay, so that gets us the temperature piece. And then we need to approximate the times when it's going to reach freezing. So if we were to approximate these times, we can type it in the calculator. You guys know how to undo sine? Like if we were to solve for this. So let's say I wanted to figure out when is it 32 degrees. So 32, I'm going to plug in for my temperature y equals the 5 sine of the pi over 12 x plus 34. Okay, so if I wanted to solve for a variable inside of sine. Yes, Charles? Nope. Close enough. So we're going to subtract the 34, so we get negative 2 equals our 5 sine. And then we can divide by 5. So we have negative 2/5 equals our sine. Now I need to figure out how do I undo sine. Anybody got an idea? It's not cosine. It's the sine inverse. Good. So anytime you want to undo something, we use the inverse function. They didn't come up with like the inverse of multiplication is division, right? They didn't come up with a fancy name. They just called it sine's inverse. So on your calculator, you'll see it's sine with that little negative 1 on it. So we take the sine inverse of both sides. 2/5. That will undo sine. So this will equal our pi over 12x. Okay. So then we can multiply by 12 and divide by pi. So our x value will equal the 12 sine inverse. And this looks ugly, but it's just a number, and you can type this in the calculator. Okay. So that's just a number. Now, when it types it in, what's a little bit interesting is your sine values will actually only show you the first 90 degrees and the negative 90 degrees. So as you're looking at this, a sine function, the values you'll get are actually just here to here to here and here to here. So this is the piece that it'll give you. So if you were to type that in, it actually tells you that the value is negative 1.5. Which for us, negative time doesn't make any sense. But if we look at this situation, if I'm at noon and I go backwards an hour and a half, where did I end up? What's noon minus an hour and a half? 10:30 a.m. So 10:30 a.m. is also over here. Okay? So even though this is about negative 1.5, for us, what we want to look at is, oh, it's just back an hour and a half, so it must be here at 10:30 a.m., which is what the back of the book will tell you. Okay? Now, the other thing is, with a sine function, what do I know about this side and that side of the curve? Similar to like a parabola. They're symmetrical, so they're the same piece, okay? So not only am I an hour and a half behind noon, I'm also an hour and a half in front of midnight. So you'll see the other solution is at 1:30 a.m. So those are the two pieces you'll see in the back of the book. Okay? So even though the calculator will spit out negative 1.5, you'll know that there's actually two pieces where, and if we think about it visually, you're like, oh yeah, there's 32 degrees. There's going to be two spots where I'm 32 degrees. And so those are your two times. Hour and a half before noon and after noon. Okay? So you have a question, some of that. We'll get some more practice tonight on it. But that's probably the most complicated piece, is grabbing all of this, creating the equation, and then being able to solve for it. Okay? And then the very last piece that you guys will look at tonight is, if you're given the equation, go find all the information about it. So in this case, what's my amplitude? 120. What's my period? What's my B value? Pi over 12. So if I know that pi over 12 equals 2 pi over my period. Good. I can multiply by p, multiply by 12. We'll do the cross multiplying thing, right? And so we'll see that p, in this case, will equal 24. Awesome. Okay, and then we want to know my horizontal and vertical shifts. So one small thing to note, this one's a little bit tricky. You want it in that form of the y equals a sine minus c plus d. Right now, c is not by itself yet. It's inside this parentheses. So you have to distribute this through so you can get c by itself. So then you see that this actually could be written as the pi over 12t minus 6 times pi divided by 12 would give us pi over 2. So I see that my horizontal shift, or my c value, is pi over 2. And then we don't have anything outside, so our vertical shift is 0. Yeah, Charles.
Will you have to specify which direction?
If it's positive, I know you're going to the right. So again, it's minus c, so c is positive, we're going pi over 2 to the right. If you told me negative pi over 2, I assume you're going left. Cool. All right.